Okay, so lesson 5-6 is talking about inscribed angles. Now, we've talked about inscribed circles, right? Circle inscribed, we talked about them like inside a triangle. An inscribed circle just barely hit the edge of each side, remember that? Okay, so inscribed angles are angles that hit the edge, right? So, yeah. So, an inscribed angle, pass that back, please, has its vertex on the circle. So when the vertex is on the circle, the two sides of the angle are chords of the circle, right? Because they go right through the circle. This arc, just like before, with central angles, is called the intercepted arc. So I like to describe that intercepted arc as if you covered up everything in this diagram except for that angle that we're talking about, angle ACB. Cover everything up. In other words, this would be blacked out and this would be blacked out. And the only thing you could see is that angle that we've defined there. The intercepted arc is that little piece of the circle that's left. It's the piece you can see. Sometimes I describe this. Imagine the angle that you're talking about as an alligator mouth, right? And the arc is what that alligator is chomping on, right? This is the alligator mouth. And the arc is that piece of the circle that's inside the alligator's mouth. He's going to eat that piece of the circle, right? Well, when the alligator opens his mouth 20 degrees, he can eat a 40-degree arc. When he opens his mouth 30 degrees, he can eat an arc that is 60 degrees. Because of this theorem, the measure of the inscribed angle is half the measure of the intercepted arc. So in other words, if this is, let's say, 80 degrees, if we, don't forget, if we drew the central angle, it matches the 80 degrees. But when we stretch this angle back to the vertex being on the circle, then this angle becomes 40 degrees, half of the arc. Okay? Okay, so what does all that mean? That means that a whole bunch of special things happen. And so this lesson is really that one concept. But we can see what that concept creates in these other corollaries. So this one says, if two inscribed angles in a circle intercept the same arc. So in other words, this angle, where's the intercepted arc of that angle? Oops, I don't know how that happened. Right there, right? Well, now look at this angle. What's the intercepted arc of that angle? Same arc, right? So it says if two inscribed angles intercept the same arc, then these two angles have to be congruent. Because whatever that arc is, if that arc is 100 degrees, how many degrees is this angle? No. 50 degrees. And how many degrees is this angle? 50 degrees. Right? So if it's the same arc that's intercepted, then it's going to be the same degree measure. So they're congruent. Again, that's the same concept. That it's not a different idea. It's just something to notice that happens because of that idea. All right? The second corollary says an inscribed angle in a semicircle is a right angle. Well, here's the angle we're talking about. Think about the alligator. He's opening his mouth 90 degrees. If he opens his mouth 90 degrees, how many degrees is the arc that he can eat? 180, right? So this is just saying that if there's an inscribed angle of a semicircle, then that inscribed angle has to be 90 degrees because it's half a 180. Again, same concept, just something to notice. All right, and corollary 3 says, the opposite angles of a quadrilateral inscribed in a circle are supplementary. Haha. Okay. Well, when you have a quadrilateral, inscribed, meaning the endpoints are right on the circle. Basically what that is two inscribed angles. This one and this one. Right? Or the other two opposite corners, but I picked these two. Right? There's basically two inscribed angles that connect at the same endpoints. Well, let's look at the intercepted arc of this. The intercepted arc of the blue angle is this green arc right here. Yes? You guys see that? If I covered up everything else except the blue angle, the piece of circle that would be left would be that green piece. You guys see that? Okay? The intercepted arc of the red inscribed angle is this yellow arc. You guys see that? Right? If I look at this inscribed angle and I cut off everything except for that inscribed angle, the arc that's left is that yellow arc, right? Okay, well if you take the green arc and you add it to the yellow arc, how many degrees do you get? It's the whole circle, right? 360 degrees. Okay, so if the inscribed angles are both half of their arcs, then the two inscribed angles added together have to be half of the two arcs added together. So what are the two arcs added together again? 360. So what are the two angles added together going to be? 180. So that's what this corollary says. The opposite angles, this one and this one, right? These two angles, added together will equal 180. Remember that word for adding to 180 is supplementary. Okay, so let's do some of these together then. In circle O, what is the measure of angle A? So you might look at this and be like, huh? Okay, so I'm going to give you the other tip that sometimes gets you unstuck. And the other tip is just look for diameters. Diameters often get you unstuck as well. Okay, so here's a diameter. So this angle is an inscribed angle, and its intercepted arc is how many degrees? So this is 90 degrees. That's corollary 2. What are the measures of angles A, B, C, and D? Well, we have to find them individually. All right, measure of angle A. Well, here's angle A. Again, think about it as an alligator's mouth open. The arc that this alligator is eating is this entire arc here. So how many degrees is that entire arc? So how many degrees is angle A? Which is? No. Measure of angle A is 95 degrees. Actually, let me write it down here. Half of 190, which is 95. Okay, Now, we could do the same exact process to find the measure of angle C. Add the two arcs together, cut them in half. But think about corollary 3. The angles across from each other, the opposite angles, are going to be supplementary. So if A is 95, no, C has to be supplementary to that. 180 minus 95. Because it's supplementary. All right, now let's do angle D. Angle D, the entire arc is what? 206. So the measure of angle D is half of 206, which is 103. And now the measure of angle B, again, we could do that same process again and add 64 and 90 and take a half. Or we could just say, since these are supplementary, we're going to be 77 degrees, right? So it's 103 plus measure of angle B equals 180. Does that make sense? All right, let's look at number 3 together, and then we'll practice them on our own. Well, actually, we have a little bit more to do on the back here. What are the values of A and B? Well, there's a lot of deductive reasoning here. It's kind of hard to see what 60 degrees is going for, but I believe that's this angle right here. Angle PQT is 60 degrees. So how many degrees is A? This arc. Yep. So one of the tricks that I suggest and I allow during a test and everything is taking some index cards on your worksheet that you're doing and using them to cover up everything except the angle you're looking at. It's hard to see on the smartboard, but if you cover everything up and just look at what's left, it helps you to identify what the intercepted arcs are. Sometimes it gets confusing because they add in like a lot of stuff, and you want to just isolate what you're looking at. Sometimes putting an index card on this edge and an index card on this edge and covering everything else up isolates that intercepted arc. So we can see that if this is 60 degrees, the intercepted arc is A, so that would be 120 degrees. So then let's look at B, because B is this angle. It includes this 30-degree arc here. So if that was 120, then the whole thing is 150. And so B would be half of 150, right? Which is? Yes. I'm going to have you try number 4, A, B, and C. See how you do with that before we add on this little extra piece here, which is, I promise, still related to the same exact concept. So try A, B, and C. Be careful on B here. This is not the center of the circle. It is not. Does it look like it is? It's not the center. Therefore, these are not central angles. So you cannot figure out what this degree measure is based on this arc. You can't do it because it's not a central angle. What you have to do here is isolate your angle 2 is what you're trying to find, and it's related to this arc right here. It's going to be half of that red arc, right? So you have to figure out what that red arc is based on the other clues in the diagram. This clue is that that's 38 degrees. So you could say, well, let's double 38 and get 76, and then take half of it to get angle 2. But what does angle 2 turn out to be? 38. So going through that process works, right? Double it and then take a half. But this is really corollary 1 that said if two inscribed angles have the same intercepted arc, then those two angles are going to be congruent to each other. So if we realize that these two angles, the green and the red, have the same intercepted arc, we could say, oh, well, then 2 has to be 38 as well because of that corollary. That makes sense? What did A turn out to be? Measure of angle 1. 90 degrees. Because this is a diameter, that makes this a semicircle, and so the inscribed angle is half of 180 or 90. That was corollary 2. Okay, so let's look at C. This is a diameter, which means angle 1 and angle 3 are both intercepting a diameter. So measure of angle 1 is 90, and measure of angle 3 is also 90, right? Right angles. But if we talk about the measure of angle 4 now, measure of angle 4 is this angle here, and it's intercepting this entire arc. So that entire arc is how many degrees? 140, right? 60 plus 80. So therefore, measure of angle 4 is going to be how many degrees? 70 degrees, half of 140. Now, how can we get measure of angle 2? 180 minus 70, because it's going to be supplementary to angle 4. So measure of angle 2 is going to be 110. The last concept here, like I said, it's really related to the first concept. And the first concept, the only concept in this lesson, is that an inscribed angle is half the degree measure of its intercepted arc. Well, this situation shows a little bit more of a unique angle. Not an inscribed angle, but one that's a little bit off-center, basically. Imagine this series of diagrams kind of in motion. Like if you have this vertex is on the circle at point A, that's an inscribed angle, right? The intercepted arc is this BC. Okay, now if I slide A down and put it here, same intercepted arc. I didn't do anything to the intercepted arc. Has the degree measure of angle A changed? No, it's the same intercepted arc. It's going to be the same degree measure. Now I slide it down some more. And then I slide it down so far that point A is actually the same as point C. It's in the same spot. Is this still an inscribed angle? No. Because what's happened here is we still have this chord going through the circle, but now this chord, or this side of the angle, is not a chord anymore. It's a tangent to the circle. So it's a little bit different because it's not an inscribed angle. It's an angle with one side that's tangent and one side that goes through the circle. But the reason why I'm saying it's the same concept is because you can still think of this as the alligator mouth, and you can still think of this as the arc that the alligator's swallowing. He just happens to be choking on this particular piece of whatever it is, right down to the bottom of his throat. But it's the same thing. He can open his mouth 30 degrees and swallow an arc that's 60 degrees. So even in this situation where the angle, still the vertex is on the circle, but instead of two chords as the two sides, where the two sides go through the circle, one chord and one tangent. So the back of this alligator's throat is basically right on the circle, and the chord, the arc, is right there. But it's still half the measure of the angle is still half the measure of the intercepted arc. Okay. Now, notice that if you do this the other way, so let's say that this arc that this alligator is swallowing is, let's call it 100 degrees, just for easy numbers. What would be the degree measure of this angle? Remember, it's still half the measure of the intercepted arc. So what would it be? 50. Okay. Now, imagine that we look at the angle that's going in the other direction. In other words, the angle that's forming a linear pair with 50. How many degrees is this one going to be? 130, because linear pair, right? So how many degrees is this intercepted arc going to be? If the angle is 130, I'm talking about this arc here. The alligator can open 130. He can swallow an arc that's 260. Do you see how this makes sense? Because between these two alligators, they're swallowing the entire circle, right? And that's 360 degrees. So it works both ways. This is a very limber alligator, can open his mouth really far. If you had an alligator that could literally open his mouth flat, he could swallow the entire circle, which is 360 degrees. And his mouth is open flat, which is how many degrees? 180. Right? It still works. Even though you're talking about a flat, straight angle, it still works. The degree measure is still half the measure of the intercepted arc. Okay, so let's try 5 and 6. Maybe we'll do 5 together. In the diagram, SR is tangent, and the measure of angle of arc PMQ. See, pay attention to the symbol there. It's arc PMQ. So start at P, go to M, end at Q. It's 212. They're asking the measure of angle PQR. Start at P, go to Q, end at R. They're actually asking for this degree measure. So there's several ways to do this. You could figure out what the remaining arc is, because the angle we're talking about, that red angle, is the alligator swallowing that arc. Or you can figure out what this angle is and then do the linear pair to it. It's going to work both ways. Okay, you want to do that one first? All right, so if we want to figure out what this arc is, the whole circle is 360. Subtract the 212. All right, so that would be 148 right here. And then the angle measure would be half of that, so 74 degrees.
Are we decorate today, or do we have
The other way to do it would be find this angle, which would be half of 212, or 106, and then a linear pair to it would be 74. Okay, so try this last one. Pause the video and try it, and then come back and check your answers. This one is 35 degrees, so the intercepted arc is double that, which is 70. And since this is a diameter, the other arc here is 110. So y is going to be half of 110, or 55. Okay.